Welcome to today's deep dive. I'm really glad you're joining us because today we're tackling a challenge that genuinely keeps engineering leaders awake at night.
Oh, absolutely. Security teams, too.
Right, exactly. Security teams and compliance officers. We are looking at how to balance that intense, relentless pressure to ship cloud-native software fast with the absolute necessity of maintaining strict security and compliance.
It's the central tension of modern tech, really. I mean, the old Silicon Valley mantra of move fast and break things just doesn't work anymore.
Definitely not.
Or at least it doesn't work when the things you're breaking include sensitive customer data, critical infrastructure, or strict regulatory compliance. You simply cannot afford to break those things.
You definitely can't. So to figure out how to avoid breaking those things, today's deep dive is based on a massive stack of comprehensive cloud governance playbooks.
Right.
And detailed implementation roadmaps for AWS security and some really cutting-edge DevSecOps guides.
It's a wealth of material. And looking at all these sources together, they all point to a massive paradigm shift in how we have to handle risk in the cloud. We're moving away from treating security as an afterthought.
And that brings us to our core mission for this deep dive. We're going to unpack exactly how you can embed GRC, that's governance, risk, and compliance, directly into your CI/CD pipelines.
Yes.
We're going to explore how to automate AWS security governance and how to track executive KPIs that prove your security is actually working to the board. And the crucial part.
Doing all of this without slowing down your DevOps speed one bit.
Exactly.
That's the holy grail, speed and security coexisting.
Yeah.
But getting there requires rethinking how we build software from the ground up.
Okay, let's unpack this. The core problem we're facing here is a fundamental clash of timelines.
Right.
On one side, you have modern SaaS companies pushing code to production dozens, sometimes hundreds of times a day.
Yeah, hyperspeed.
But on the other side, traditional GRC relies on manual checklists, massive spreadsheets, and these agonizing end-of-cycle security reviews. It's a slow, human-driven process trying to govern a hyperspeed machine-driven process. It simply can't keep up.
It's like trying to monitor traffic on a modern superhighway using a horse and buggy. The traditional GRC model was built for the days of quarterly software releases.
Right.
When you're shipping code multiple times a day, traditional compliance becomes a massive bottleneck. The solution, and what our sources emphasize heavily, is the concept of shifting security left.
Shifting left. You hear that phrase thrown around a lot in tech circles, but what does it actually look like in practice for a developer on a Tuesday afternoon?
Well, it means moving security and compliance as early in the software development lifecycle as physically possible. You don't wait until the software is built and sitting on a staging server to check if it's secure.
You check it while it's being written.
Exactly. In this new model, your CI/CD pipeline, continuous integration, and continuous deployment, which is essentially the automated conveyor belt getting code from a developer's laptop to an AWS server, is no longer just a delivery mechanism. The pipeline is the new control enforcement point.
It becomes the bouncer at the door. But the sources also highlight a major hurdle here, which is cultural friction. If you suddenly drop a bunch of security gates into a pipeline, developers usually rebel because it slows them down.
That is the single biggest point of failure in these implementations. The developer friction is real. If a security tool throws 500 warnings and 490 of them are false positives, developers will just find a way to bypass the tool.
Yeah, they just want to ship their code.
Right. So the playbooks are very clear. To make shift left work, you have to meticulously tune these automated tools so they only flag critical, actionable issues. You have to build trust with the engineering team.
That makes a lot of sense. So looking at the pipeline itself, the sources provide a specific breakdown of the automation layers you need. First up is SAC, or Static Application Security Testing.
Yes.
This involves tools like SonarCub or checkmarks. These tools scan the raw source code before it's even executed. They're looking for things like SQL injection vulnerabilities or messy coding practices right there in the text.
Right. It's essentially an automated spell checker, but for security flaws in the code your team is actively writing.
I can see how that catches your own mistakes. But modern software is basically built on borrowed parts. We don't write everything from scratch. How does this pipeline handle third-party talent?
That's where you layer on SCA, which is software composition analysis. Tools like SNCC are scanning your third-party libraries.
Yeah.
Because you might write perfectly secure code, but if you import an open source library that has a known flaw, you're still completely exposed.
Oh, absolutely.
SCA checks all those dependencies for known vulnerabilities, often referred to as CVEs, and it even checks for expired software licenses, which is a huge legal compliance issue.
That's vital for supply chain security. Then moving down the pipeline, we have secrets detection. The playbooks emphasize this heavily. Tools like Git Guardian run on every single pull request to catch leaked AWS access keys or database passwords before they are permanently committed to the code repository.
What's fascinating here is how quickly a leaked secret can be exploited. If an AWS key hits a public repository on GitHub, attackers can compromise your environment in literal seconds. Secrets detection stops that at the developer's commit stage. It's a lifesaver.
Now, once the code and the secrets are checked, we have to look at the infrastructure itself. The sources talk about container and IAC, standing IAC being infrastructure as code.
Yes. Today, we don't manually configure servers. We write code that tells AWS to build the servers. So you use tools like Trivy to scan your container images for vulnerabilities, and tools like Checkoff to scan your Terraform or CloudFormation templates.
That prevents misconfigurations before the infrastructure even exists.
Yeah.
And this brings us to a concept that completely blew my mind in the reading, which is policy as code, or PAY. The sources specifically highlight a tool called Open Policy Agent, or OPA. How does this fit in?
Policy as code is where the magic really happens for compliance teams. Instead of writing a security policy in a Word document that says all databases must be encrypted, you write that policy in code. OPA acts as a decision engine in your pipeline. Let's say a developer writes infrastructure as code to spin up a new AWS RDS database, but they forget to toggle the encryption flag.
A super common mistake.
Very common.
Yeah.
When that code hits the pipeline, OPA evaluates it against your policy as code. It sees the missing encryption flag and automatically denies the deployment. It kicks it back to the developer with a message saying RDS databases require encryption.
Wow.
The insecure database is never even created. You've completely automated the enforcement of a compliance rule.
You know, it makes me think of an analogy. Imagine your automated CI/CD pipeline is a high-speed toll booth on the highway. But this toll booth automatically x-rays your car for safety issues while you're driving through it at 100 miles per hour. It checks the brake, the engine, the tires.
I like that.
And it only drops the barrier, which in DevOps terms is a failgate if it detects that your brakes are actually cut. Otherwise, you just keep cruising at top speed.
That's a perfect way to visualize it. The failgates are entirely automated. If a tool finds a critical vulnerability, the build stops. A Jira ticket is automatically created, a Slack alert is sent to the developer with instructions on how to fix it, and the bad code does not go to production.
And what I love is how this translates to the compliance side.
If we connect this to the bigger picture, these aren't just technical tools for developers to play with, they are living, breathing compliance controls. For example, a GRC analyst needs to prove to a third-party auditor that the company follows secure coding practices. Well, that automated SaaS scan in the pipeline, that directly satisfies ISO 27001 and SOC 2 requirements for secure development and threat prevention. The logs from that automated pipeline literally become your audit evidence.
You're automatically generating your audit homework while you build the product. It's brilliant.
Okay.
So that's the pipeline side of things. But once the infrastructure is actually out there living and breathing in AWS, we have to talk about how we govern it in the wild.
And that conversation starts with understanding the AWS shared responsibility model. This is a fundamental concept that companies get wrong all the time.
Right.
AWS secures the hardware, the global network, the physical data centers. That's their responsibility. But you, the customer, are responsible for securing everything you put in the cloud. You own the configuration, the identity and access management, and the data protection.
Here's where it gets really interesting. The sources outline a real-world threat scenario that perfectly illustrates what happens when you fail at your end of that shared responsibility. Let's walk through the compromised developer credentials scenario because the timeline on this is terrifying.
It's a classic and unfortunately very common nightmare for security teams.
Here's the setup from the playbook. A developer is working late, maybe trying to push a hotfix before the weekend, and they accidentally commit a live AWS access key to a public GitHub repository. They bypass the secrets detection tool we talked about earlier.
And the attack happens almost instantly. It's not a human hacker sitting in a dark room finding this key. Within minutes, automated malicious bots that constantly scrape GitHub harvest those exposed credentials.
And what do they do with them?
They use them to log into the company's AWS environment programmatically and immediately spin up hundreds of EC2 instances. EC2 is essentially renting out massive fleets of Amazon's virtual servers.
Right.
But they aren't hosting websites. They're using these massive servers specifically for crypto mining. They're racking up tens of thousands of dollars in compute charges by the minute while simultaneously attempting lateral movement to access your sensitive customer databases.
It's a worst-case scenario. Human speed detection, like an analyst checking logs the next morning, is entirely useless here. The damage is done. But the sources detail exactly how automated AWS governance stops this cold. It breaks down into 3 phases: prevention, detection, and auto-remediation. Let's start with prevention.
Prevention is about limiting the blast radius before the key is ever stolen. This means enforcing MFA or multi-factor authentication across the board. But more importantly, it means enforcing strict least privilege policies.
Meaning you only get the keys to the specific rooms you need to do your job.
Exactly. If that developer's leaked key only had permission to access one specific development database rather than having full administrative access to the entire AWS account, the attackers simply wouldn't be able to spin up those crypto mining servers in the first place. The AWS platform would just deny the request.
But let's say the key did have some broad permissions and the attackers get in. That brings us to the detection phase.
You can't manually watch your AWS logs 24/7. You need a tool like Amazon GuardDuty. GuardDuty uses machine learning to continuously monitor your environment for unusual behavioral anomalies. It instantly detects that this specific AWS access key is suddenly making API calls from a geographical location you've never operated in.
Oh, wow.
Or it detects the highly unusual pattern of spinning up a massive fleet of expensive servers at 2 a.m.
So it spots the anomaly and triggers an alert. But an alert sitting in an inbox while the security team is asleep doesn't help anyone. The bill is still climbing.
That is where auto-remediation comes in, and it's the most critical part of modern cloud governance. GuardDuty doesn't just send an email. It's configured to trigger an AWS Lambda function.
And a Lambda function is just a piece of code that runs automatically in response to an event, right?
Spot on. This Lambda function automatically executes a pre-written response. It instantly deactivates the compromised access key, revokes all active session tokens associated with it, and drops a high-priority Slack alert to the security team detailing exactly what it just did.
So the threat is identified, contained, and resolved in minutes, not hours or days. The attackers are locked out before they can do any real damage or rack up a massive AWS bill.
And the security team wakes up the next morning to an incident that is already closed with a full audit trail of exactly what happened and how the automated system fixed it.
That is the power of automation. And beyond responding to active threats, the sources talk about guardrails you can put in place to prevent entire categories of mistakes from happening at all.
The playbook highly recommends using service control policies, or SCPs. These act as organizational guardrails at the highest level of your AWS account. For example, you can write an SCP that absolutely forbids the creation of a public S3 bucket, which is essentially a cloud storage folder anywhere in your company.
So even if a developer has administrative rights and tries to make a storage bucket public, the SCP overrides them and blocks it. You're legislating safety at the platform level.
Precisely. And for the data itself, there are tools like Amazon Macy, which automatically scans your storage environments to classify sensitive data. It looks for PII, which is personally identifiable information, or PHI, protected health information, things like credit card numbers or medical records.
Right.
Macy tells you exactly where your regulated data lives, which is half the battle in compliance.
Knowing your data, restricting access to it, and automating your response to threats. So what does this all mean for the business? We have all these amazing automated tools in the pipeline and in AWS, but how do you prove it's actually working? Especially to the leadership team, the board of directors, or a third-party auditor who doesn't know what a Lambda function is.
That's the critical bridge between the DevOps engineers and the executives. GRC has to move away from static point-in-time audit reports. You know, the kind where your compliance team spends 3 weeks gathering screenshots of server configurations just to prove you were secure on one specific Tuesday in October.
Which frankly proves absolutely nothing about how secure you were on Wednesday.
Exactly. It's security theater. You have to shift to real-time dashboards using tools like Grafana Splunk or AWS Security Hub. If the control enforcement isn't visible, it's not verifiable. You need continuous compliance monitoring where the board can look at a screen and see the current state of security.
The playbooks actually provide a very specific GRC scorecard for leadership to look at. They outline 5 executive KPIs, key performance indicators that really tell the story of your cloud security posture. Let's go through them because this translates the technical jargon into business value. KPI number 1 is the percentage of IAM policies enforcing least privilege. I imagine that's essentially a metric of how tightly we're locking the doors before anyone even tries the handle.
Precisely. IAM identity and access management is your foundation. Tracking this percentage proves proactive access governance. It tells the board we are actively ensuring that users and systems only have the exact permissions they need and nothing more. If this number is high, your potential blast radius for any incident is significantly reduced.
Moving to the second KPI, mean time to detect, or MTTD, I'm guessing this is where the guard duty alerts we talked about earlier come into play. How heavily do boards weigh this metric compared to just preventing attacks altogether?
Boards care deeply about MTTD because prevention isn't foolproof. This measures how long it takes your systems to spot a threat once it's inside. As we saw in the compromised credential scenario, a shorter MTTD means the attackers have less time to operate. It proves to leadership that your massive investments in monitoring tools are actually paying off.
Which leads right into KPI number 3, mean time to remediate, or MTTR.
Once you detect the issue, how fast do you fix it? This shows leadership how quickly misconfigurations or active vulnerabilities are resolved. A low MTTR proves that your incident response is agile, and it shows that you're successfully relying on the automation we discussed, like those Lambda functions, rather than waiting for humans to click buttons.
KPI number 4 is a big one for regulators, the percentage of workloads with full encryption coverage.
This is a major trust signal. It shows that data at rest sitting in a database and data in transit moving across the network are both protected. If you can show an auditor a live dashboard proving 100% of your databases and storage buckets are encrypted, you eliminate a massive area of regulatory concern almost instantly. Remember that OPA policy we talked about?
Yes.
This dashboard is how you prove that policy is working.
And the final KPI number 5, the monthly count of auto-remediated violations. This one feels a bit counterintuitive. Wouldn't you want this number to be 0?
You'd think so. But a 0 means your automation probably isn't catching anything. This raises an important question for leadership. Are we just identifying problems or are we actively fixing them? Tracking auto-remediated violations proves that your governance system is self-healing. It shows that your automation is catching inevitable human errors and fixing them without human intervention. That scales infinitely better than trying to hire 10 more security analysts every time the engineering team grows.
I want to share a mini case study from the sources that brings all of this together perfectly. It's about a fast-growing healthcare SaaS company. They were in a really tough spot. Because they were scaling rapidly, they were pushing code 20+ times a day to keep up with their market. But because they're in healthcare, they were completely drowning in manual audit prep for ISO 27001 and HIPAA compliance.
It's a very common growing pain.
Yeah.
The engineering speed completely outpaces the compliance team's capacity to verify safety.
Exactly. The GRC team was spending weeks just hunting down evidence, begging developers for screenshots of configurations. It was burning everyone out. So they changed their approach. They embedded tools like GitGuardian for secrets, Trivy for containers, Checkoff for infrastructure, and OPA for policy as code directly into their GitHub Actions pipeline. They essentially built that high-speed X-ray toll booth.
And the crucial part, what did they do with the data from those tools? Because tools alone don't solve the GRC problem.
They routed all the metrics from those automated tools into a shared Grafana dashboard that the GRC team and the auditors could access. And the results were transformational. They moved their GRC program from a paper-based reactive nightmare to a real-time proactive system. They could mathematically prove continuous control operation to their auditors at any given second. And the best part,
It accelerated their delivery.
it actually did. Developers got instant feedback on security issues in their code editor instead of waiting weeks for a manual review board to reject their work.
It's a perfect example of how security, when engineered correctly into the workflow, is an accelerator, not a brake.
So as we wrap up today's deep dive, I want to bring this back to you listening right now. Why should you care about all this alphabet soup of tools and KPIs? Well, if you're a DevOps engineer who is completely exhausted by manual security reviews that constantly block your deployments, this automated pipeline approach is your way out. It gives you your speed back. And if you're a GRC analyst who is tired of begging developers for screenshots to give to auditors, this approach gives you continuous, undeniable proof of compliance without having to nag anyone. This methodology turns governance from a bureaucratic bottleneck into a massive business enabler.
I couldn't agree more. If we connect this to the bigger picture, my final thought is that we really need to change how we view these historically opposed departments. When GRC and DevSecOps share the CI/CD pipeline, compliance is no longer a separate reactive chore that happens after the fact. Instead, compliance becomes the natural automated outcome of properly enforced technical controls. You build the pipeline right. You tune the tools to respect the developer's time, and the compliance simply proves itself.
That is the ultimate goal, isn't it? And I want to leave you with one final, slightly provocative thought to ponder. We've talked today about how our infrastructure is now entirely written as code. Our security policies are written as code using tools like OPA. Our compliance evidence is continuously generated and monitored by automated dashboard systems. If all of that is true and the data is perfectly structured—
How long until the regulatory audits themselves are conducted entirely by AI?
Exactly. Without a single human auditor ever needing to look at a screen or ask for a document, it's coming a lot faster than we think. Thank you so much for joining us on this deep dive. We'll catch you next time.